So now we're going to operate the instrument. So the sample has been loaded into the cassette. The cassette has been loaded into the instrument. We are in position 0. The software is open. So now I'm going to turn the instrument on using the software. It can also be done just by pushing the on buttons here, but I'm going to specify exactly the conditions I want before I turn it on. Okay? Cool. So I know you guys can't see. If you want to come on this side, that's cool. Here's ChemStation. It's not the very latest version, but we have later versions, and I've used them, and they're the same. So this is kind of I consider it a nice resume item, if you can say you're familiar with ChemStation. So if you want to work in the sector, it's like, oh cool, they can be ChemStation. It means you're armed. Now I'll explain briefly, in general, a point about almost all the analytical instrumentation software has these 3 parts. It has a method part, where you specify the operating conditions of the instrument. Things like pressures, temperatures, wavelengths, flow rates, etc. Right? That goes into the method, and times and things like that. Then there is another layer called the sequence, which essentially has to do with how the autosampler is going to introduce things. And the sequence almost always also includes a set of calibration standards and then the samples. So method, sequence, and then there's another part which varies a little bit more, and that's the report generation piece. And that the latter is not the focus of my instruction to you now, so we'll use the default there. But let me get right to it, and we'll turn on the instrument. And from ChemStation, that is accessed through the instrument menu, and I'm going to say first setup pump, and we're going to go water is set to 40%, and I'm going to change that to 60 by changing the methanol. Changing the methanol to 40. Okay. Now I'm going to add some acetonitrile, and you simply click on the up arrow, and we'll change that to 10%. Now I'm going to change the methanol to, oh my goodness. Change the methanol to 30. So now we have 60, 30, 10 set up. Flow rate of 0.75 mils per minute. Stop time of 5 minutes. Post time of 10. Maximum pressure of 400, minimum of 0 bar. So with these settings in, we'll go ahead and OK this dialog. That'll transfer that to the module. Now go instrument, more pump, control, radio on and on. Now you can hear the instrument start up, hear the pump start to clunk away, and we'll let the pumps run for a few minutes. Now I'm going to set up and start the. It's called the DAD, stands for diode array detector. And I'll start with setup DAD signals. The default is 254 nanometers. It's just a generic mid UV wavelength where almost all aromatic systems have at least some absorbance. It has another wavelength here, B, which is an insignificant difference. It's at 255. There's kind of a lot to this, but I'm just going to leave it now on the single wavelength. I'll OK this, then I'll go instrument, more DAD, control, and lamp on, and OK. So now the DAD lights, you'll notice, the on and off are both illuminated. That means that it's warming up. The pump light is on. And now within a couple minutes we'll be able to actually initiate a run. Things kind of have to warm up just a bit. Alright? So, at this early stage, we're just going to run this one sample, right? And so the software settings require a specification of a method. So I'm going to go up to Method, Edit Entire Method, OK these dialogues. Now this is an existing method called jamie.m. And if I change it, I'm going to save it to a new file name so that I don't mess with poor Jamie's method, so she gets screwed up next time, okay? And I may not change very much. There's the pump specification, 0.75 mils per minute, 5 and 10 minutes for the stop time and the post time. I'll explain what those are later. Pressure limits of 400 and 0. That's an overpressure limit. The pressure will drop precipitously if there's a leak. So both of these are thresholds for clogging and leaking that will turn off the pump. And I'll OK this dialog. Temperature control we're not using, so this is ignored. The injector volume of 5 microliters is fine. Anywhere between about 2 and 10 microliters should work okay. Here's the wavelengths that are set up. We're not going to do anything too fancy with them right now. The signals that are going to be recorded are 254, 255, and 230 nanometers. These have to do with doing quantitative analysis, and we don't need to add any additional signals there. This second to last dialog shows some settings that you can change depending on how intense the peaks are that are coming out. This is a little artificial intelligence program that makes a guess as to whether or not a particular elevation in the detector signal should be considered a chromatographic peak or not. And essentially, if you get a lot of perceived peaks that are not real, you have to decrease the sensitivity of this by giving it, for example, a larger area reject, a larger peak width, or a lower, I should say a higher slope sensitivity. But we'll keep these defaults for now. Here's the report specification, and we're not going to change that in this incarnation. We'll OK that. There's some other display issues. We're going to OK that. I'm going to put a post run of shutdown, and I'm going to say OK. So hopefully when this, after this runs, it'll shut itself down. You can see the absorbance is being traced versus time here. The lower graph shows the diode array absorbance signal. Now, we can either use the auto sampler or we can do a single vial. In this case, we're going to run a single vial. And I'm going to specify vial 0 in this dialog right here. The file is going to be recorded as the prefix RTDC, and then the extension to the file is going to be 001, 2, and 3 for subsequent iterations of this method. Okay? We can talk a little bit more about these things, but for the moment I'm just going to say OK. And now this is looking reasonably stable, so I'm going to click on Start. And now, if things are working properly, which most things indicate they are, you can see the auto sampler is going to inject. And there it goes. And now within a few minutes the peaks should begin to show up on the chromatogram. This red line indicates 0 retention time. And now within a few minutes we should start seeing some peaks appear on this time axis as the absorbance of the injected analytes begins to appear on the spectra as they are shown here. So the diode array detectors actually take a spectral snapshot every second or so, and you can see that. I'll increase the sensitivity here briefly so that as the trace analytes elute, we can see their spectra here. So now there's an important time called the dead time, which is the time it takes for the analyte to get from the sample to the injector, or sample from the injector to the detector, assuming it's not retained at all. And that dead time is probably about now, and we can see some analytes start to come out. Now that particular spectrum looks a lot like caffeine. And you did the UV vis of caffeine, so you may be able to recognize it as it elutes here. Right? And then you can also see contextually why we ran the UV vis in advance, because it shows you what wavelengths you're most sensitive to. So the absorbance at just one of these wavelengths is recorded versus time. Right? And so the selection of the wavelength determines the relative sensitivity that you have towards different analytes. Okay? So on this short column, things elute pretty quickly, but so far it looks like we have a pretty decent separation on the caffeine from other analytes. And in a few minutes this will elute and we'll be able to look at the report.